Hello class, this is lesson 7-2 titled How to Use the Converse of the Pythagorean Theorem. So we remember the Pythagorean Theorem was telling us that if you have a right triangle, then you take the squares of the legs and add them together and it should equal the square of the hypotenuse. So the converse is saying that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then you can conclude that the triangle itself is a right triangle. So this is basically saying that if a squared plus b squared is equal to c squared, then triangle ABC is a right triangle. Okay, so it's kind of working backwards by having sides, and then we can conclude that it is a right triangle or not. So our first example is going to deal directly with that. It's asking us this question: is this a right triangle? So looking at it, I have three sides, and I'm going to try to determine using the Pythagorean theorem if it's a right triangle or not. So again, I'm going to write down a squared plus b squared is equal to c squared, and see if this holds true when I plug in the values. So one of the legs is 9, one of the legs is 15, and one of the legs looks a little different. It's 3 radical 34. So we just need to make sure that we're careful when we're doing our calculations. 9 squared is 81, 15 squared is 225, and then when we take 3 radical 34 and we square that, we're going to square the 3, so that's going to be 9, times radical 34 when you square it is just the number 34. Okay, so let's check here. 81 plus 225, that is 306. And when I multiply 9 times 34, I also get 306. So yes, it is a right triangle. Awesome. Let's do another example. I have another triangle. Let's just figure out if this one is a right triangle. So again, we're going to do the a squared plus the b squared and see if that's equal to c squared. Let's plug in our legs, or the shorter sides, since I don't know if they are legs. So I have 10 as the shortest, and 11 as the second shortest, and 14 as the longest side. So 10 squared is 100. 11 squared is 121, and 14 squared is 196. These are all perfect squares that you should have memorized. So this right here is 221, which is not equal to 196. So in this case, no, it is not a right triangle. As much as it might look like it is, it's not. Okay, so let's move on. Theorem 7.3 tells us that if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. Okay, so this is where the Pythagorean theorem does not hold true, and basically what it's saying in this case is if c squared is less than a squared plus b squared, then the triangle is acute. Okay, so that's kind of cool to know. Also, I have another theorem very similar. This is theorem 7.4, and it says if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is an obtuse triangle. So this one is now saying that if when you find c squared, if it holds true that it's greater than the sum of the squares of the other two sides, a squared and b squared, then the triangle is obtuse. Okay, so if it's equal, it's going to be a right triangle. If it's less than, it's going to be acute. And if it's greater than, it's going to be an obtuse triangle. Sweet. So we're going to finish off with one last example. Okay, and in this example, it's asking us if the lengths of these segments, 4.3 feet, 5.2 feet, and 6.1 feet, can form a triangle. So this is going back several sections where we learned how to figure out if 3 different lengths can possibly make a triangle or if they're too short to make a triangle. So what we're going to do is we're going to add up 2 sides and see if their sum is greater than the third side. So we just need to do this for all 3 different scenarios. So 4.3 plus 5.2, that equals 9.5, and 9.5 is greater than the third side, which is 6.1. Also, I can do 4.3 plus 6.1. When I add those, I get 10.4, and that is greater than the third side, which is 5.2. So that one works. And then let's add the other 2 sides. 5.2 plus 6.1, that I get 11.3, and I find that that's greater than 4.3 by quite a lot. So it holds true for all 3 of those cases. So yes, this can form a triangle. So whenever you're asked if these can form a triangle, this is what you need to do to show that, yep, it's possible. Okay. Now the second part is where it's wanting to know if this triangle is an acute triangle, a right triangle, or an obtuse triangle. And so to do that, we're going to use the format of the Pythagorean theorem. The only thing that we don't know is if the c squared is equal to, less than, or greater than the sum of a squared plus b squared. Okay? So let's just fill in the things that we know. The c is always going to be the longest side. So in this case, 6.1 is our longest side. And then the a and the b can be either one. So 4.3 squared plus 5.2 squared. So when I square 6.1, I'm going to get 37.21. And I still don't know what this is, so I'm just going to draw an arrow down. 4.3 squared is 18.49. And 5.2 squared is 27.04. Okay, I'm going to add these together. And 37.21 is going to remain on the left side. And when I add them together, I get 45.53. So now I can fill it in. That's definitely less than, which is telling me that this is going to be an acute triangle. And I'm done. So this is primarily what we're going to be working on in this section. I hope that it was pretty straightforward for you. If you do have any questions, just come with them when you come back to class tomorrow.